whether it be, monitoring for safety of pandemics, human engineered bioweapons or nuclear war, we already face extinction level risks as a society. And I think AI can really make a difference in how we might tackle those.
Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app. And we'll keep sharing amazing conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. I'm also an investor in and advisor to more than 30 AI-first companies, and a firm believer in the power of technology to make humans better. If you're passionate about changing the world with AI, or maybe just looking for your next adventure, let's talk. We learn from AI thought leaders weekly on this show, and the added bonus is you get one AI fun fact each week. Today's fun fact comes from what we will call the Captain Obvious files. Let's just call this the case dismissal heard around the world. We've all been waiting for someone in power, say an attorney, to be exposed relying on fake information invented by ChatGPT. Well, it happened. This past week, a New York attorney representing an airline passenger had his argument summarily rejected because it contained references to court cases that didn't exist. Unbelievably, Stephen A. Schwartz, who conducted the research, told the court, and I quote, he was unaware that the content generated by ChatGPT could be false. Let that one sink in for a minute. Expect more of this ahead while, as an industry, we implement better guardrails for both explainability and auditability. As always, we'll link to the full article in today's show notes. Now, shifting to this week's conversation. Today's guest is a self-described serial entrepreneur focused on beneficial uses of AI, which is just one of many reasons we get along. Ron Bodkin founded ChainML in April 2022 to make it easier to integrate AI models into applications. The AI we know today is immature in so many ways, and many of them relate to how crude the tooling is for traditional developers building AI-first features. The ChainML protocol is cost-efficient, decentralized, and built for compute-intensive applications running on blockchain technology. Prior to founding ChainML, Ron had a distinguished entrepreneurial career, having founded Think Big Analytics before it was eventually acquired by Teradata, after which Ron spent 3 years in applied AI at Google. Ron's also an active investor and advisor and has degrees in computer science from McGill and MIT. Thanks to mutual friend Scott Wharton for the reintroduction to Ron. And without further ado, Ron, it's my pleasure to welcome you to the podcast. Let's get started by having you share a bit more about your background and how you got into this space.
Yeah, thanks, Dan. We definitely mentioned a few areas where I've been working and some of what I've been doing. I had studied artificial intelligence back in undergraduate and grad school, but at the time it was different techniques, symbolic techniques and probabilistic techniques were just coming into play. And then I got involved in entrepreneurship around the explosion of excitement around the internet, co-founded a company that went public. But I got back into AI at a company, Quantcast, that was a pioneer in applying AI techniques to ad tech, building lookalike models. And, have ever since then been building and working on AI. I've believed that it's going to have an incredibly profound impact on the future. And I think that's increasingly a mainstream view that people realize how big this technology is going to be. But I've also, for the last several years, been really focused on how do we make sure that we build AI that's going to have a positive impact on the world. One of the motivations for me, a big motivation in starting ChainML, was to create a direction where AI can be both controlled and people have more choice over how AI impacts them. I really was worried and continue to be worried about a future where AI is controlled by a small number of powerful companies that decide for everyone how it's going to be implemented. I think that would be a very bad future. So sincerely hope that we're able to foster a better one where we have control and predictability in the AI, and it's doing great things in a way that's democratically governed.
As a technologist, do you think that the current wave of technology, innovation, and also just cultural enthusiasm for generative AI, would you consider that more evolutionary or revolutionary?
I think it's revolutionary because what we're seeing is this big crossover point. It really, those who are inside the AI field saw this 3 years ago, and everyone observed it when ChatGPT came out, which is you now are having AI models that are very capable at a wide variety of tasks, right? The stunning thing when OpenAI published the paper describing GPT-3, and when everyone experienced ChatGPT, is you could tell this model to do a huge variety of things in natural language, and it's quite good at it. And of course, there's a race to make them better and better, but you've got this big shift to a world where we have these powerful general purpose models that can do many things well, instead of previously we had extremely narrow AI that did one thing well. And so you need to have a team of PhDs and specialized data to get it to do anything. And so, the biggest tech firms could afford that. Like, when Google was working on search or, doing recommendations in Facebook, they would hire a team of experts and build a narrow AI model to solve that one problem. But it was very inaccessible. Now it's feasible to take a GPT-4, a Claude, a Llama, open source model, and use it for a whole variety of tasks. And a lot of times what you see is, from a technical standpoint, you'll see a steady increase in capability, but you see a kind of grokking or a sudden emergent change that something starts to really come through. And so this ability to accept and respond to natural language instructions and do useful tasks is a big change. So that's quite revolutionary because it changes the way people can build software, build AI systems. And then behind that, what you've got is these models are being trained on superhuman amount of knowledge, right? Like the reason that we're already seeing, GPT-4 come in with, top grades, top 5% grades on all kinds of, knowledge exams, college board exams, and so on, is because it's memorized and internalized a representation of the internet. I mean, I think it's, we're already, of course, seeing evolution to say, hey, multimodal, not just take text, but take video and images and many other forms, audio, right? Many other forms of content. But the ability to take in this massive amount of information in a general purpose system is really powerful. I mean, I think Jeff Hinton put this well in a recent interview. It's like, we have to recognize that we've actually invented a superior form in many ways of learning than the human brain. And, we're not constrained by the evolutionary constraints. Like, human brain was limited by how much food a person could eat and how much of the energy could be allocated to thinking. But we're putting, millions of times that amount of energy into AI systems. We don't have those constraints anymore. And so we're building systems that are much more powerful. So I think it's revolutionary.
You and I've had some good recent discussions about some of the limitations for developers of building generative AI first applications or features. And I think the public, having essentially been exposed to a very simple, crude chat interface on top of the GPT models, either 3.5 or 4, has very narrow expectations about where the technology can go. As developers, we know how we're struggling because of the lack of proper tooling and infrastructure. Talk a little bit about more about the state of developer tools and infrastructure to support some of these big ideas that entrepreneurs have about where they can take the technology.
Yeah, absolutely, Dan. But what we see is there's a real hunger to build more specialized applications that use generative AI, right? So how do you have agents that can do more sophisticated, capable tasks for you, right? So that might mean helping you do deep analysis on a variety of data or research, whether it be around trading or around a product idea or around how to improve an operational process, even just how to let people create a fair bit of automation to simplify their job and take some drudgery away, right? So there's a lot of these areas where building more sophisticated agents would be incredibly powerful, right? We see a lot of companies wanting to build that into the user interface of their applications. But, where we're at right now is that there's one approach, which is to integrating large language models into applications, which is, not really taking advantage of the power of AI, which is, rigid chains like A, then B, then C. And I'm going to use, some hacks like trying to use a regular expression to parse out the output and hope that the model will produce something that I can sort of recognize. So this kind of rigid chaining tends to be really brittle and inflexible. So that tends to be very hard to maintain. The other side is, there are people trying to build agent frameworks. You might have heard of AutoGPT or Baby AGI, where the idea is give it a general purpose goal and it will try to solve it for you. However, they're pretty simplistic. The control structure is basically take your best guess and then operate based on that. So when you have a complicated task, breaking it down into a series of subtasks and then iterating on each of those tasks, what tends to happen, pretty much all the time is it gets stuck, goes off into a ditch, started to doing something that's irrelevant, and it gets confused. And 30 minutes later and $50 later, the user's like, I don't know what this did and why it's working on this subtask, but it's not helpful. So, we think that, the idea of having agents is a good one, an important one. It's going to be needed to drive more leverage from the use of these models, but you need to have control. You need to know how it's working, know when to ask a user for input. You need to have budget. You need to have the ability to assess and look across different options, right? And I might say, if you think about an analogy, other AI systems have become much more powerful by exploring alternatives with planning and search and then deciding the best direction, right? So AlphaZero achieved, the world-class chess and Go play by doing Monte Carlo tree search. In chess, AlphaZero will look at thousands of board positions each time it takes a move. It's a weak amateur if it just says it's a one-ply search and say, let me look at each move and decide which is the best board position. It does search in a smart way to figure out how to play well, right? And so, this is an area we've been investing. We've built a framework to make it possible to build agents with sophisticated planning, with budgets that know how to explore and find the best path, right? So this is something we're planning to release and open source in the next couple of months.
You mentioned Jeff Hinton's comments and the difference between how we've been able to help these large language models learn versus how the human brain learns. But the fact is, one of the big limitations right now is that the human brain is vastly more powerful and actually more efficient at decision making, specifically when it comes to rational thinking, which machines are not good at doing. If you agree with me that cost and performance are holding back broader adoption of AI-related innovation, do you see anything on the horizon, even if the horizon is 5 years or a decade, where the cost and the performance of these models at a broad range of tasks could get us on a path to where anything that anyone would call anything close to AGI would even be in the realm of reality?
Yeah, well, I'd say first, I think human brains are also actually quite bad at rational thinking, in the sense that the way that what we understand, and I'm not a neuroscientist, but as an amateur who's read a little bit, the way our brains, do math or logical reasoning is a very convoluted, inefficient system, right? That it ultimately comes down to some pretty low level mechanisms, of that arose around, the same mechanisms that arose in animals that don't have rational thinking in the way we think of it. So, we already build it's an emergent property of a fairly complex structure, mostly our neocortex, right? So it's not clear to me that the way that a large language model does math and reasoning is necessarily built on a worse substructure. Now, it's true that the human brain has an unbelievable amount of processing power, incredible amount of processing power, and very rich parallel processing. It's evolved, and so there's an interesting question of if Hinton's right, and I think he may be, that we'll actually get better performance for unit compute power out of AI systems, that they're actually a superior computing technology than human brains, pound per pound, if you will, that we may get the ability to have intelligence in AI systems with less computational power than a human brain actually has. But I think it's fair to say they're different. So I think we should say it's a weak prior that the amount of computation a human has is something like the amount that an AI would need to achieve AGI is there. Now, one thing I think is a good way of looking too is this concept of effective compute, right? So if you take the combination of the cost of computing, algorithmic improvements, and increasing amounts of capital being invested in to AI, at least for training the state-of-the-art models, the effective compute is doubling every year, right? And I've heard arguments, like Jan Talon, for example, will say, hey, we probably have line of sight to 1 million times better, which would be 20 years of that process of doubling, right? And if you imagine something where you use 1 million times more resources than a GPT-4 or a Claude, like these are powerful models, right? Like it's not at all clear that they won't be at AGI level. And of course, I think it's also a little odd when people say, oh, well, let's fix the techniques. Software improvement means you aren't fixing the techniques, right? Like what are a couple of things that are obvious limitations that you can see work on improving? Well, one is, how do you make it possible to give larger amount of input into these models so that they have more context? And there's a race to do that, right? Like Anthropic just announced a model that takes in 25 times more input than GPT-4's base model, and they have a bigger one that's a bit slow, right? So there's a lot of work on how do you innovate on more input. Obviously, there's a ton of desire to improve on incremental learning rather than big slow training runs to relearn everything from scratch. So I think that there's debate around the ability to have other forms of knowledge representation that might be more efficient. And there's lots of debate around is transformers that are this key thing that have been the foundation of AI. Is that the thing that's going to carry us forward? It's only a 5-year-old technique, and there were techniques before. So it would surprise me if that's actually the dominant technique 10 years from now. But you add all of those things up, and I think it's very possible that within 20 years we could get to AGI. I think we have to be humble and say our track record of forecasting future scientific progress is terrible, right? I mean, people, predictions months before nuclear fission happened, that nuclear physicists said that it was nowhere close, right? I mean, there's been all kinds of examples where experts have gotten it wrong. So we have to approach with some humility. If we knew how to create AGI, we would have a better idea. And we have to also be humble that we have a very poor understanding of intelligence itself, right? It's still incredibly empirical. People train new models and then they try to figure out what it'll do and what has emerged. That's also a source of risk. But the point is, it's hard to predict. But I think it's clear that we're going to have far more capable AI systems, even if they're not AGI, over the next decade and beyond. In fact, I think the returns, the amount of economic value that's going to create is going to accelerate capital investment massively in the space.
I'll try to unpack jargon for our listeners. AGI, artificial general intelligence. And question for you, building on those comments, I believe that as humans, we have very limited expectations for what the future of AI or generative AI holds because of how narrow it is of what we've been exposed to so far. I've heard only about 1% to 2% of the sum total of the world's knowledge can be codified or has been codified in text, which is what the LLMs are based on. Given that the vast majority of the world's knowledge is represented outside of text and certainly outside of the Common Crawl from 2021, which was used to train GPT, what has to happen for these AIs to be able to navigate the real world or have kind of spatial intelligence that is what humans are so good at having, that is such a big part of perception and sentience, or that those advanced kinds of learning that we attribute to humans, that today it's just comical. When we see how simple these text-based models are, they're phenomenally good at using stats to predict the next word or token. But when it comes to having to do real work in the real world and build these spatial relationships, what's your thought on what's the technology or even the research leap that needs to happen before we can think about some of those other kinds of tasks?
Yeah, I think again, this is an area where we can say there's a lot of uncertainty. I mean, I think it was interesting. The researchers at Microsoft published a paper looking at GPT-4 called Sparks of AGI. And one of the examples they gave is the text-only model of GPT-4 before it had ever been trained on images. You could ask it to draw a picture of a unicorn. It would do it in a kind of vector graphics that can be represented in text. And it got better and better. So without ever having looked at a picture, it was really good at generating pictures. So, let's not discount being able to absorb this superhuman amount of information and what concepts are there, because predicting the next token ultimately means predicting human thought. And so already we can see that even a GPT-4, just from text, has learned a lot about spatial reasoning to be able to draw increasingly accurate pictures. So, but then we have to stop there, because guess what? The end product of GPT-4 is a multimodal model that takes in images too, right? And there's lots of work on AI systems like DeepMind's Gato that take in large amounts of not just images, but videos and gameplay, and easy to do simulations, right? So there's a lot of ways that this information could be fed in. There was research not long ago at Google where they took a lot of these techniques and were able to create quite powerful general purpose robotic systems using these kinds of generative AI models and use them to control arbitrary robots reasonably well. So, I agree, like robotics and operating in physical domain is a more challenging space, but I don't think, I think it's a real open question of, is there going to be some, what's the rate of progress? There's already a lot of work on multimodal information. And it's true, like a lot of information is in video, right? So being able to pull video data in and use it for AI systems will be a direction of advance. I think one thing that will slow down progress in AI is you're seeing more walled gardens around high value data sets as more and more companies say, we don't want our data to be used for somebody else. So you get these islands of maybe YouTube videos, for example, may only be used for AI trained by Google. And, maybe TikTok will do a deal to give access to their data to another AI company. And, is it an accident that Twitter has shut off API access and Elon Musk has started X.AI to make his own AI? That will slow things down, right? Because you'll take these pieces of knowledge and fragment them. And so they'll be only those who have access to the specialized data. That certainly is bad from the standpoint of letting academic researchers and open source be able to build useful things and even have some level of transparency around what's being done. But I think that will slow progress if you have more and more of the splintering of data into sets that only one organization can use for AI training.
It'll also make access to generative AI significantly more expensive. All of those providers will either force you to access their LLMs behind their paywall, or they'll license it to OpenAI or some foundational model. And then that organization will have to pass the cost on to the consumer.
Yeah, I think that's right. That will be that can be a direction to raise costs and slow progress in it. That's true.
Ron, you and I share a passion for, I know what you call beneficial AI. I talk a lot on this podcast about the need to exercise AI responsibly. We'd love for the audience to get to know what beneficial AI is to you, and then specifically as you're building ChainML, how does that permeate the way that you're building product?
Yeah, I mean, so for me, there's a lot of great uses and value in AI, right? I mean, building delightful experiences that empower people, giving them the ability to focus on the parts of their work that they're really excited by, and remove a lot of drudgery in the work. The ability to enable people to do creative things where they don't necessarily have all of the technical skills that might traditionally be required. The analogy might be, I'm sure when cameras came out, a lot of painters thought that was cheating and it was awful that anyone could create accurate images instead of having to have years of technical training in painting. And, there's all kinds of hard scientific and engineering problems that AI can help us with, right? Like being able to address health and come up with better therapies. And, increasingly we see that aging is a root cause of many diseases. And so being able to address aging, being able, as well as, cancer and heart disease and dementia, being able to address climate change, whether it be designing better materials, operating more efficiently, improving engineering around carbon capture in different scenarios, right? There's such a wide range of areas where advancing science and advancing engineering with AI can have huge positive impact. So I think there's a lot that we can benefit from, and I think it's always going to be taking a balanced perspective of benefits versus risks, right? I think we need to move on from the techno-utopian view that there's only good from building new technology, and start with a view of like, this is going to be powerful, but let's start from the beginning and say, how do we put things on a track where we get the benefits and we mitigate the risks? And usually mitigating the risks has to start with understanding the risks, right? So, I might just comment that I think it's important that we continue to have independent academic researchers be able to really understand and independently probe and do research on what are the risks as we're building more and more powerful and capable AI systems, right? So I think that's and also frankly have funding for that, right? So I think the most important thing that we can do, at this time where AI is exploding is, number one, make sure that we're not having the most powerful AI systems in the world cloaked by trade secrecy and no accountability. And number two is actually fund a significant amount of work on understanding AI, understanding the risks, measuring how to control it, making sure we know how to determine risks in practice before we start widespread deployment of capabilities that are brand new.
Everyone listening should rewind that answer. Listen to that a few times. Ron, that was really well articulated. So we recently got a 22-word statement from Sam Altman and as well as some others, warning the global leaders that if we don't regulate AI, could be on a path to extinction of the species. And then interestingly, perhaps not coincidentally, that came the same week as Elon Musk's Neuralink got FDA approval for implants in human brains to be able to do things like allow people who are amputees to walk again. Now, wow, that's quite a spectrum. want to get your perspective, if you even agree with that spectrum, somewhere between extinction and AI curing cancer and solving famine and global warming. Where are you on that spectrum, and what's the data that you use to back up where you are on that spectrum?
Yeah, I mean, certainly I share the concern about risks, that this is potentially the most powerful technology we'll ever invent. And so we absolutely have to make sure it goes well the way we implement it and execute it. I put in to sign that same statement, unlike the pause, which I thought, had some doubtful nature, as a bit of it didn't have a very coherent call. I mean, I think the good thing about the one thing, simply we need to regulate it because there's extinction level risk is absolutely correct. I will say, I think it has the potential to address extinction level risks as a society, in humanity as well. There's, whether it be, monitoring for safety of pandemics, human engineered bioweapons or nuclear war, we already face extinction level risks as a society. And I think AI can really make a difference in how we might tackle those. So it can also be helpful. And I'm not sure if we're on such a bad path with climate change, it's extinction level risk, but it certainly presents a tremendous amount of risk to us, and it can help with that. But, I would say, creating something that has the potential to ultimately be much more intelligent than us, really does take some deep thought and reflection. I think the dimension of that risk is, a lot of it has to do with how quick the takeoff is. How quickly will we get improvement in significantly better capabilities? I think historically the way we address problems is that we tend to observe some problems, and as you get issues, you go and course correct. So the most scary scenario is fast takeoff, where you have no time. Suddenly you've got this super powerful system that, is not understood, and it's very easy to see where that might go wrong. But, I think we will see friction in the development of more and more powerful systems that, you don't, when you think about, like, people are engaged in science, they don't just sit in a corner and think abstract thoughts. They come up with hypotheses, but then there's a lot of work to go build things, to gather data, to experiment, to test, right? And so I think the resources to build more and more powerful AI systems are going to be, I think, will continue to be exponentially harder, right? In a sense, we already have super intelligences pursuing artificial general intelligence, which are the biggest corporations in the world, right? So I think that makes me more optimistic that we'll have slower takeoff. And with slower takeoff, it means we have more opportunity to observe the problems and take action to correct them. And it's also emerging in a milieu where, I think a lot of times when people talk about the risks of AI, there was this view of a kind of a lab leak where you would have like one secret lab that was building AI and get domination, like the most powerful AI in the world. And that's not the way things are going at all. We've got a race where, maybe it's a bit reckless and we don't have enough control and safety, but you're seeing still, dozens of companies with funding to build AI, and certainly a handful of leaders where billions of dollars are being spent to build powerful AI systems, right? And so that means you're not going to have a single AI that's going to, in any likelihood, be significantly ahead. And of course, it's not really the AI models, but it's the systems they're deployed in is sort of where risk comes from, right? So I think that gives us the opportunity to course correct and measure, but I still worry if we're going to put the resources in to do that, right? It's easy to see a path where we ignore the dangers until things get so bad that it's too late. I mean, you only have to look at social media and see how long we let things go in terms of, like, what are the harmful effects on mental health and misinformation and democracy before we even started acting. And frankly, we still haven't acted, even if there's general view that there's real problems here. Like, the policy answers around what do you do to mitigate those issues in social media are weak, right? And so if we follow the same kind of path with AI, where in 10 years from now, we're like, wow, it's incredibly powerful at manipulating things, and unethical corporations are able to build, super Enrons using AI, and we don't know how to regulate this thing. We're in deep trouble if we get there in 10 years, right? So how do we not end up in that future where we're on track to end up in a dystopia where AI is empowering the worst actors in driving terrible behavior, right?
Some of the early feeble attempts at regulation, things like the AI Bill of Rights that was proposed last year, to me are comical in that, it's really easy to get together and spew a bunch of platitudes. It's just obvious. But as technologists, you and me and our listeners are going to be responsible for actually implementing this. And, I don't want it to seem as silly as the state of Colorado saying they're going to ban TikTok. I mean, these things are easy to say, but they're impossible to implement and govern. One approach that's coming up a lot in academic circles for regulating or governing what AIs can do is using GANs, generative adversarial networks, to essentially monitor or enforce the decisions of AI. So you'd actually have AI challenging AI and kind of guardrailed potentially by, in a technologically robust way. That's just one thing that's, at the experimental phase. What's your thought about going to the next level, given that these dangers exist? Any thoughts on the technology that we should be thinking about, or maybe that create opportunities for entrepreneurs where we could start to answer these questions in a way that's defensible?
Yeah, I mean, I think it's certainly true that having multiple AI systems interact to check one another is a good approach, as well as scalable oversight so that you can allow humans to have some level of weighing in, and technically various efforts to understand better the internals and characterize them so you can better determine what a system knows or believes or how it's functioning. Those are all useful, right? So in the vein of understanding using AI systems to govern each other, there's the technique AI safety through debate is an early effort in that direction, and I think that's becoming increasingly practical, as well as maybe derived versions. Likewise, mechanistic interpretability techniques to better really understand how models are working are useful. I think, there will be ongoing technical efforts, understanding and having the ability to prove or understand and control will be important. I think regulation, to the point, I think the biggest thing that we can and should do is actually a positive thing of put a lot of funding into research around safety, controllability, understandability of AI systems. That will actually create benefit in terms of letting us build good AI systems, but it will greatly shift the balance, where right now you look at it and you look at huge AI research labs, and just a few % of the people working there are working on safety, which includes understandability and controllability of these systems, right? And so, it's like you can argue, and I think you should argue, that including safety in a system should be an inherent property, right? Like, imagine if we had an engineering discipline for bridge building where 98% of engineers were off building bridges without a concern for safety. And then there was a whole separate department of bridge safety engineers who are out there talking about, we really need to make these bridges safe. Every year, bridges are collapsing. This is really bad, right? Like, we need to change the way the system works. But for now, where it's not such a core thing, putting a lot of investment in that, I think, is important. I think, there's people who are saying, they throw out there and say, well, we should basically create a high bar around an understandability of AI systems. So write regulations that require a level of understanding that doesn't currently exist. I don't think that's a realistic proposal, right? To basically, because what that comes to is like, ban AI until there's research advances that let you meet this criteria. Like, that's not going to happen. People aren't going to do that. And if they did, it's like, if one country did that, the other countries, commercial competitors would be like, that's great. We'll jump in and we'll race ahead, right? So I don't think that's going to do it. So I think, beyond that, like I said before, I think, regulations so that independent researchers can study and measure risk in powerful AI systems is really important. I like what the Europeans did in the social media space on this with the Digital Services Act, where very large online platforms with 100 million or more users a month in the EU governments can mandate that researchers get access to the data and internal systems to do their own risk assessments on those systems, right? To be able to do research, and override privacy concerns. Obviously, you have to have strict rules around privacy and what can be done. But by analogy, you really need to have independent oversight and review to say, let's understand the risks and measure them. So I don't know how you regulate anything without calibrating the risks. And if it's all trade secrets and you have no way of measuring the risks, then you get into people, instead of scientifically studying risk, you get into people telling stories and saying, well, this might be happening and this might be happening. And, rightly, we have to be skeptical about writing, costly regulation around scenarios that are hypothesized without evidence, right? So we need independent oversight, independent review to understand the evidence, to quantify risk, to demonstrate risk. And then that will let us have standards, which can be both liability standards, right? So I happen to think this is a really good point Robin Hanson makes is, we should be doing a lot to say, what are the things that are risky behaviors that could lead us to bad outcomes, and put heavy fines around taking steps in those directions, right? So that companies steer away from things that will take us in a bad direction, but then also allow for certification with independent audits to say, of the known risks, right? We'll then create a market structure where you can go to any certified auditor and they can go out there and assess you against those risks and say, yeah, you qualify. And so by creating a private market, you can have innovation from different technology companies to say, hey, we're going to do a better job of monitoring and understanding this, right? So, you already see companies out there like Fiddler or Armilla or Parity that are out, in various ways addressing some of the known risks. Like right now, one of the risks that's really well understood, and so there's a lot more traction, is around unfair bias, and which is great to have the ability to measure and have accountability around that. It's just that I think so many of these other risks, like we don't know how to say what is manipulation and deception in an AI system, but it's kind of important. People are, to also be able to have regulations around that, right? And what do we do with the fact that we know that today's AI systems hallucinate and do give misinformation, right? Like, should we ban them because they're not perfect? Probably not, but where's your line? What's a reasonable threshold around accuracy of the system? And what does manipulation mean anyway? And is there a difference? I think there's a difference in having, mass personalized manipulation versus, what does social media do where it's taking more standardized content, but then with recommendation algorithms targeting it, or even, traditional advertising that was manipulating people to some extent, but just, in a more broadcast means, right? So there's a lot to think through here, but I think these are some of the areas we really have to think about. And then, of course, there's also a basic level of safety of how do you avoid just malicious uses, like people creating autonomous weapons, people planning criminal activities, all kinds of things where there's some clear risk that more and more capable AI systems will allow these, and we can't allow providers to enable those use cases, right? We have to have ways to prevent against those as well.
Ron, we've gone way over time, and this has been fascinating, but you're not getting off the hot seat without answering one last question for me. So let's say we're having a version of this conversation in 2033, not 2023. What's one behavior that is commonplace then that today would just seem like science fiction?
I think we're going to find that everyone's becoming a manager of a whole team of intelligent assistants that are doing all kinds of work for them. So the scope of ambition of what people seek to accomplish will be amazing, right? Like people will talk about I'm going to work on this hard scientific problem this week and make progress on it, which today is like, are you kidding me? That's like a career goal. And like, suddenly it's like, no, you could actually get good at orchestrating and making progress on hard problems in a week or a few weeks instead of a career.
Well, we've started so many discussions, probably a dozen discussions that warrant their own full episodes. I hope you'll come back and maybe explore some of these topics more.
That would be great. Enjoyed the discussion, Dan. Great talking with you today.
Likewise. Well, Ron, I can certainly say that on behalf of me and all the listeners, we're all rooting for you and the team at ChainML to succeed.
Thank you.
Well, that's all the time we have for this week on AI and the future of work. As always, I'm your host, Dan Turchin from PeopleRain. And of course, we're back next week with another fascinating guest.